Welcome to Creata classes. In this lecture, we will cover circumference and area of circle, sector and segment. Circles have slightly different concept of finding area as it does not have any sides. So its concept of finding area will be different from triangles and quadrilaterals. But before that, let's see what is the circumference of a circle. Circumference is the total length of the boundary of the circle. This is similar to the concept of perimeter. Here in the circle, the linear distance of the boundary of a circle is known as circumference. We can use a thread or a wire to measure circumference of a circle. Just we have to measure the length of the boundary, that will be the circumference of the circle. Before moving further to the concept of the circumference, we will understand the concept of pi. You might have seen this symbol. This is known as pi. So firstly, we will understand the concept of pi. After that, we will move to the circumference. We will understand this with a small experiment. Okay? I do these small experiments to make the concept way to your subconscious mind. I can directly tell you the formula of circumference and the area of the circle, but I will take you to the final formulas through the path of basic understanding of the concept. This will help you in long run. So just be with me and enjoy the experiment. I always say that you are most welcome to try the experiment with me. It will enhance your basic fundamental. So let's begin with the experiment. You can also try with me by pausing the video. Let's take three different circles of different diameters, say 6 cm, 10 cm and 14 cm. We have to measure circumference of these circles. Let's take a thread and measure the boundary of the circles. Okay, circumference is the linear distance of the boundary of the circle. We will get the circumference of first circle as 18.8 cm. Check with your figure. Have you also got the same length? Similarly, the circumference of second and third circle will be 31.4 cm and 44 cm. This is approx length. You might have gotten some mistake in the mm. Small error can be ignored. Okay, so we have got all the circumference of these three circles. Now the next step is we will take the ratio of circumference to the diameter of these three circles. The ratio of circumference to diameter of the first circle will be 18.8 by 6, that is 3.14. We have got the ratio. Let's find the same ratio for the second circle. It will be 31.4 by 10, that is 3.14. Oh, we have got the same ratio as of the first circle. What a coincidence. Let's take the third circle. The ratio will be 44 by 14, that is 3.14. Oh, again the same value. This shows that ratio of circumference to a diameter of a circle remains same, that is 3.14. Whatever size of circle you will take, the ratio of circumference to the diameter will always comes out to be 3.14. You can check so. Take a huge circle and calculate the ratio, it will be 3.14. So we got that this ratio is constant, and in mathematics this ratio has a special significance. This ratio is called pi and it is denoted by this special symbol. It is also written as 22 by 7, which will comes out to be 3.14. Pi has much greater significance, but we will limit ourselves to this limit only. So we got circumference over diameter is equal to pi. So here comes the formula of circumference, that is circumference is equal to pi into diameter. And we know diameter is twice of the radius, that is circumference is equal to 2 pi r. This is the famous formula of circumference of circle. This is very famous. Now you got how this pi comes into the formula of circle. This is the fundamental that you should know. I would have directly started with this formula, but the concept of pi is very must for generating the basic fundamental. So moving further, let's move to area of the circle. Let's have a circle. We have to calculate the area of the circle. Let's divide the circle into equal parts. Let's take these parts out of the triangle. Let's take half of the parts on the upper side and half of the parts on lower side. Let's join them. We got a figure. Are you able to observe this is somewhat resembling a rectangle? Not a perfect rectangle, but somehow closer to the rectangle. Let's again divide the circle into equal parts. This time we will divide it into larger number of sections. Let's take half of the part on upper side and half on the lower side. We got a figure. This figure is now somewhat closer to the rectangle. The point I want to focus is that as we keep on dividing the circle into more parts, our final figure after reassembling of the parts will more look like a perfect rectangle. If we divide the circle into infinite parts, our rectangle will be fully perfected. And area of this rectangle is equal to area of the circle, because this rectangle is formed from the circle only. Both area will be equal to each other. And we know area of a rectangle is equal to length into width. So firstly, let's find the length and width of this rectangle. For this rectangle, this side will be equal to radius of the circle. Any issue, this is equal to radius. And what will be this side? For that, we again have to go back to the first figure. Here we will better understand it. We have divided the circle into these parts. We know circumference of circle is 2 pi r. We have just calculated. Means this distance is 2 pi r. And we have placed half of circle parts on upper side and half on lower side. Means we have divided this 2 pi r into two parts. Half on upper and half on lower. That is 2 pi r by 2 is equal to pi r. Means pi r on upper side and pi r on lower side. So we got the length of the rectangle as pi times r. So let's calculate the area of the rectangle, that is length into width. That will be r into pi r, that is pi r square. This is the formula for area of the circle. Okay, pi r square. This is also very famous formula. So we have got circumference of circle as 2 pi r and area of the circle as pi r square. This formula, you have to remember it. This will be used all over the mathematics and in physics and other studies too. Circumference 2 pi r, area pi r square. Let's take an example. Find the circumference and area of the circle of 5 cm radius. So its circumference will be 2 pi r, that is 2 into 3.14 into 5, which will comes out to be 31.4 centimeter. And the area will be pi r square, that is 3.14 into 5 square, which will be 78.5 centimeter square. This is the answer. Just a small caution to show you the implementation of the formula and use of pi. You can use pi as 3.14 or 22 by 7. Both are same. Okay, we have done with the circumference and area of the circle. Let's move to our next subtopic, that is area of sectors and segments. Let's take a random circle and let's draw two radius. This will be minor arc and this will be major arc. The area between two radius line and this arc is known as sector. This is minor sector and the larger one is major sector. You can imagine a slice of pizza. This is the best way to remember the sector. The pizza slice is having two radius line and the arc. Further, let's understand the segment. Let's take a random chord in the circle. Chord is basically a line segment joining 2 points on the circle. The chord has divided the circle into two parts known as segments. This is minor segment and this is major segment. This is sector and this is segment. You can observe the difference between both of them. If we take a common arc, this will be sector and this will be segment. In this lecture, we will calculate the area and circumference of these figures. This will be very used all over the mathematics and physics, so pay your full attention please. Let's begin. Firstly, we will begin with area of the sector. Let's take a circle with center as O and the arc as AB. We have to calculate the area of this sector OAB. Let's assume the angle between the radius OA and OB is theta. So the angle AOB will be theta. We know the area of the circle is pi r square. In a way, we can consider this circular region to be a sector formed an angle of 360 degree at the center O. We can say so this complete angle will be 360. So we can say this complete circle is a sector itself with angle of 360 degree. Now by applying the unitary method, we can arrive the area of the sector. That is, when the degree measure of the angle at the center is 360 degree, area of the sector is pi r square. So when the degree measure of angle at the center is 1, then the area of the sector will be pi r square by 360. Therefore, when the degree measure of the angle at the center is theta, area of the sector will be pi r square by 360 into theta. Or we can rearrange it as theta by 360 into pi r square. This is the formula of area of the sector. Okay, very simple. Moving further, we have seen this complete boundary of the circle is the circumference of the circle. In similar way, can we measure the length of the arc AB? Can we? In the similar way, we can find the length of the arc AB. That will be length of the arc of the sector of angle theta is equal to theta by 360 into 2 pi r. This complete length of the boundary of the circle is 2 pi r, and length of this arc with angle as theta at center will be theta by 360 into 2 pi r. The same unitary method we have used. So these are the two formulas of sector. Now moving next to segment. Are you able to observe this is the segment? Let's have a random point P on this arc AB. So we can say the segment ABP is formed. Can we say the area of segment ABP is equal to the area of this complete sector, that is AOBP, minus the area of this triangle, that is OAB? We can say so. Okay, we can calculate the area of this segment as by calculating the area of this complete sector minus the area of this triangle. That is the technique to find the area of the segment. Through this technique, we can find the area of the segment. Okay, got it? So that's it for this lecture. We have done the circumference and area of circle, sector and segments. We have done with the theory part. From the next lecture onward, we will cover the problems based on area and the perimeter. Before moving to the questions, go to the download section and download the complete list of the formulas. Take the printout of the list and also add your notes while doing the problems on area and the perimeter. Okay, that will be your master formula list. This list will be used for the preparation of the examination from the school level to the competitive exam level. So best of luck. Thank you very much for being with Creata classes. Bye for now.